NOVDEC 2025 Core Mathematics Paper 2, Question 7. So let's begin with the A part. So for question 7A, we've been given the relation y is equal to 4m multiplying k plus x all on k plus 2x. Now, our goal here is to make k the solid. So that is for I. We have to make k the solid. So this is what we are going to do. I'm going to repeat the relation. Y is equal to 4m k plus x all on k plus 2x. So y can be written as y on 1. At this point, we can cross multiply. Cross multiply. So when we cross multiply, we have y multiplying the denominator. We have y multiplying k plus 2x. And this must be equal to 1 multiplying the whole of this expression. So giving 4m multiplying k plus x. Next, let's expand. We are going to expand. So when we expand, we have y multiplying k and then y multiplying 2x. So y multiplying k, we have yk plus y multiplying 2x, we have 2xy. So this must be equal to the same procedure. Let's expand this. So 4m multiplied by k and then 4m multiplied by x. So we have 4mk plus 4mx. So at this point, because we want to make k the subject, we are going to group all terms containing k on one side and all terms without k on the other side. So we have yk, then you also have another term containing k, so minus 4mk. So this must be equal to 4mx, then minus 2xy. So next, let's factorize k out. Let's factorize k out. So when we factorize k out, we are left with y minus 4m. And this must be equal to 4mx minus 2xy. So what do we do next? Since we are looking for k, we can divide each term by y minus 4m. Here we have y minus 4m. So y minus 4m will cancel out, leaving k on the left. So we have 4mx minus 2xy all on y minus 4m. So that is for the I part of the question. So that is I. We've made k the subject. Now I. We are to find the value of k when x is 3, y is -2, and m is 1. So we are just going to substitute these values into the equation. So we have k being equal to 4, you know m as 1, you know x as 3 minus 2xy. So minus 2, you know x as 3, you know y as -2. So the whole of this divided by y, that is -2, then -4, we know m as 1. So we have k. So let's simplify the numerator. 4 multiplied by 1 multiplied by 3. So we have 12. So, and then minus 2. Okay, so let's make it this way. Let's do everything together. -2 times 3, that is -6. And then -6 times -2, we have positive 12. So here will be plus 12 because -2 times 3 -6, and the -6 times -2, positive 12. So this divided by, we have -2, then -4 times 1, -4. Again, this can further be simplified as 12 plus 12, we have 24, and then -2 -4, we have -6. So finally, we have k being equal to 24 divided by -6, that is -4. Question 7b. A boat is on the same horizontal level as the foot of a cliff. So first of all, let's represent our horizontal level. So on this horizontal level, we have a cliff. So this is our cliff. We know that the cliff will always meet the horizontal level at an angle of 90 degrees. So that has been represented. Now, so we have our boat represented in the red ink. So B represents the boat. So with this, we could see that this is the boat. This height here represents the cliff. This is the foot of the cliff. The foot of the cliff. So let's represent that as F. So this point here is the foot of the cliff. And T represents the top of the cliff. Now we are told that the angle of depression of the boat from the top of the cliff is 30 degrees. So first of all, let's represent our horizontal line of sight. And we know that any angle below the horizontal line of sight is the angle of depression. So the angle below the horizontal line of sight is the angle of depression, which is giving us 30 degrees. So we have 30 degrees for the angle of depression. Now, if the boat is 120 meters away from the foot of the cliff, So this is the boot. This is the foot of the cliff. So the distance between them measures 120 meters. So with this, we are to illustrate the information in a diagram. So that is the I part of the question. So BI, we have represented the information on a diagram. II, we are to find correct to three significant figures, the height of the cliff. So the height of the cliff, that is line TF. I'm representing the height of the cliff as H. So line TF is H. So now, how do we solve for H? So we could see that we have a right angle triangle, that is triangle TFB. That is our right angle triangle. We know the length of FB as 120 meters. So we equally need an angle within the right angle triangle. And we could see that this 30 degrees angle alternates with this particular angle. So if this angle measures 30 degrees, then here must also measure 30 degrees. Because we know that alternating angles are equal. So these two angles here are alternating. So it is alternating with this. This angle also measures 30 degrees. So if that's the case, then you should be able to identify the sides of the right angle triangle. So this side here represents the opposite. This side represents the opposite because we know that the side facing the acute angle is the opposite. We also know this distance. We know that this distance here is adjacent. This is adjacent. And the remaining side, that is the longest side, becomes the hypotenuse. So we know the opposite, we know our adjacent. And because we are looking at the height, we are looking for h. So we need to refer from SOHCAHTOA. We know that from SOHCAHTOA, our focus should be on opposite and adjacent. And from SOHCAHTOA, there's only TOA that has opposite and adjacent at the same time. And what does TOA says? TOA says that the tan of the acute angle is equal to the length of the opposite divided by the length of the adjacent. So let's take note of this. So from triangle TFB, so that is the right angle triangle, we know that the tan of the acute angle, which is 30 degrees, is equal to the length of the opposite. So the opposite, that is h, divided by the length of the adjacent, giving us 120 meters. So let me repeat this. Tan 30 equal to h on 120. So tan 30 the same as tan 30 on 1. So we can cross multiply. So when you cross multiply, we have 120 times tan 30. So this gives 120 tan 30. And then 1 times h, we have h. So what is 120 tan 30? I want the decimal form. So we have 69.2820. But remember, we were asked to correct our answer to three significant figures. So we know that h is 69.2820. So let's correct the height of the cliff to three significant figures. So we have h being equal to, so there is the first significant number, the second and the third. So we have 69.3 meters. So in conclusion, we say that the height of the cliff measures 69.3 meters.